inequalities, we would graph our slope-intercept and our standard form the same, or a point slope. We're going to graph it as we usually have. But when we see an inequality symbol, that's going to change a few things. So with slope inequalities, we're shading, okay? Shading our solution set. So don't write this. Are you writing this?
No.
If I had x is greater than 3, okay, where would my circle be?
3.
On the 3, and then I would shade what or off?
But it wouldn't be filled in, right?
It would not be filled in, no. So, when I graph something, anything that's shaded is part of the solution set, correct?
Yeah.
So, 4 is greater than 3, is that true?
Yeah.
5 is greater than 3, is that true?
I think so, yeah.
Okay, no, I think so. Alright, that might not be too bad to write. I would maybe write that if you find space. Maybe over here. Not a bad thought, not a bad thought. X was greater than 3, and then show how we graphed it. We graphed it with a solution set. Because anything highlighted, anything in that solution set says it could be an answer. So now when we're dealing with less thans, we always read it left to right, correct? So if I had it y is less than, then I'm going to shade below. So if my y value is less than my slope-intercept, I'm going to shade any value below the y-axis at that point. If I how would I read this one? Y is greater than, so I'd shade above. So if I said y is less than equal to, which direction would I shade? I would shade below.
Oh shoot, who's falling off? I think that wasn't a bucket.
I don't know. That Snapchat is really popping though. And then if y is greater than, I would shade above. Shade above. So we are typically used to shading on a number line. We're still shading the solution set, it's just going to be in a graph. Now the next few things to think about, we have a boundary line. That's the line that you graph. So usually when I graph a slope-intercept equation, I start at the y-intercept, then I rise and I run, and I rise and I run, and then I just make a straight line over across it. Now that we're dealing with inequalities, the line that you were writing is either going to be a dotted line, a dashed, or it's going to be a solid line. If it is a dashed line, it is a less than or greater than.
Ooh, this makes sense because it's
Absolutely. And if it is a dashed line, whatever is on the line will not be part of solution set. So if I have a dot that is on the dotted line, that is not part of the solution set. That could not be plugged in to be a true answer. Nope, nope, nope. What do you think it is if my line is solid?
it can be anything between
It's a solid line.
Let it greater than or equal to
Oh, greater than or equal.
That was on your column. See now, Rudy?
And if it's plotted on the dotted line, or plotted on solid, that point is part of solution set. It can be plugged in. So if you have a solid line, then you would plot your dot on that line and it would be part of the solution set. I could take that x, y, plug it in, and it would be a true statement. The goal of inequalities is to make true statements. You ready to study?
Yeah.
Okay, so let's graph this. 4/3 x plus 2. I'm going to graph it like I usually do. My starting point is the 2, the y-intercept.
Yeah.
So I'm going to plot a dot at 2. And then 4/3 is rise over run, correct?
So rise 4 and go over 3.
Just like Noah said. So 1, 2, 3, 4 over 1, 2, 3. That would be my second point. Yep. And then I can't go any up more, so I'm going to go down. I'm going to go 1, 2, 3, 4 over 1, 2, 3. So 3, 6 is a point. -3, -2 is a point. To go one more. 1, 2, 3, 4 over 1, 2, 3. And -6, -6 is a point. So I start at the y-intercept and then I rise and run from there. Alrighty. Yep. Y is what?
Y is less than plus 2.
Less than. So if it's less than, do I shade above or below?
Below.
Okay, always annotate that. Always, always, always. That's going to be your work for me. So if you see y is less than, you're going to write below. Now our question, how in tarnation do we decide which is above and which is below? What I do is I pick a dot. It could be any dot. I usually pick the y-intercept. And I draw an arrow. You could even draw an arrow on a few dots. That's telling you you're going to shade below the dots. Pick the arrow and draw. So this is going to be a dashed line. And then I'm going to shade anything this way. So instead of graphing a solution set and shading a solution set on a number line, I'm shading the solution set on a graph. Y is less than, so I shaded below my boundary line. My boundary line was dotted because it's a less than situation. Noah is just so full of energy today, he's going to pass out our
I feel like I should be able to feel that one.
There you go.
If it were greater than, we would shade above.
I got witnesses right here to do feeling. No, that's absurd. They need to make more Alvin and the Chipmunks movies, yeah.
Alright, there's one more thing we're going to put on our blue page. One more thing.
Hey, Alvin.
Alright, so there's a way that we can check to see if we've shaded correctly. Maybe we got messed up, I don't know. So, the way to check, we're going to write it under here, really wherever you have room. We check with 0, 0. I forgot about this trick, or else I would have typed it in. So you can check with 0, 0. So what we're going to do is we're going to take y is less than 4/3 x plus 0, and we're going to plug in. So we're going to say 0 is less than 4/3 times 0 plus 2. So if I solve this out, I get 0 plus 2, and I get 0 is less than 2. Is that a true statement? Yes. So I could take any ordered pair. If I took an ordered pair from my shaded section and plugged it in, and it makes a true statement, I plugged in the shaded in the correct direction. Y'all are very much buzzkills on Mondays. You're just so unripe. Okay. Alright, let's switch here. Whew. Nope.
It was you, I knew it.
You better watch it back at the end. I got it on. Chris came just again. You just nah.
Alright, let's look at this one. Graph the solution set. Y is what? Y is less than negative. Okay, we're gonna pause. Read it in your head. Okay, read it to me. Y is greater than or less greater than or equal to is okay. I'm gonna mute you, Noah. You're kind of done for today. Alright, so last year on the sword test, I don't talk about the sword till we get to it, but I do want you to know they had graphing mechanisms where you had to graph the inequality with the boundary line and the shading. Alright? So graphing is an important piece that we need to know how to graph. We use Desmo so much we forget how to take a slope-intercept and graph it. So we need to keep that at the forefront. Because last year it did have like the place the dots and make the line and click which region you're shading. So what do you notice about this slope? It's negative. So if this is the left, this is the left and this is the right, my negative will start this way and go down like that, right? Okay. What point am I starting at? Negative 1. And if I have negative 2 over 1, I'm really falling 2 and running 1, correct? So I'm going to fall 2 and run this way. I'm running that way because I need my slope to be going in this direction. So that point is 1, 3. I fall 2, run 1, fall 2, run 1. You with me? So now if I go up 2 over 1, do the dots have a negative direction?
Yeah.
Then I'm good. Okay, always check that. Put your pencil down when you have your dots dotted.
Is that a word?
It's my word.
Okay.
Add it to the Grigsby dictionary. Alright, if it is greater than or equal to, which direction am I shading?
Above.
Above. So your work for me is going to be writing above. If it's greater than equal to, is it going to have a dotted boundary line or a solid?
Solid.
Solid? That's what we're going to write also. So with my line, I can go ahead and fill in a solid line. Pick a dot, any dot. What's your dot?
1, negative 3.
1, negative 3. Okay, if I'm shading above, my arrows are going to be shaded that way. I'm telling you, the arrow trick will save your life. It really, really will. So it didn't just want me to graph it, it wanted me to do what?
Shade.
Well, that's part of my graphing now. List 3 solutions. What would it mean to list 3 solutions? Ordered pairs within the shaded region. So what's an ordered pair?
1, 5.
Over 1 up 5? I agree. I'm gonna label this solution set.
4.
Over 4 up 3, I agree. What's a tricky solution that is special to this specific line? What? No. It's part of the solution. Negative 1, 1. Why is that a tricky one?
Because it's a dot.
A dot on the line itself. If I have a solid line, I can choose a dot on the line.
Oh, that makes sense.
You couldn't just choose from dots the whole time?
Mm-hmm. But if it's dotted, I cannot.
You did negative 1 negative.
Oh. Duh.
Oh, shoot.
Alright, now let's check. Which ordered pair do you want to check with? Xander, pick an ordered pair for me. From the ones we listed. Negative 1, 1. So we're going to label x, y. So we're going to plug in 1 is less than or equal to negative 2, parentheses, negative 1 minus 1. So all I did is I took the ordered pair from the solution set, and I'm plugging it into my inequality. Now let's solve it down. We're going to solve it down with jummies. So I have positive 1 minus 1. Do you agree? Negative 2 times negative 1?
Yeah.
Oh,
Two.
that's a positive 2.
Yeah.
There you go.
I'm making you feel like I'm crazy.
One day we'll just plan to gaslight you the entire period. We will pre-plan it.
Oh, okay.
And then I work it down to 2 minus 1. So if I read this inequality, 1 is less than or equal to positive 1. Is that true?
Yes.
If it makes a true statement, I have shaded in the correct direction. It is a solution set. If I can plug that ordered pair into the inequality, it will make a true statement. You feel me?
Yeah.
Pretty much.
So this one with your person. Go.
So you get like
I already even know it can work together. Thank you. He'll go anywhere. He can move.
Rise over rise over 2. Revising 2. But we're starting off negative 2. Revising 2. That because it's positive. Wait, it's negative 2 times 6. Oh. Genius. So that's 2.
Where's your arrows?
Look at dotted line, right? On which side would we choose? You wouldn't choose it.
It's not negative.
Yeah, like your slope's more slope. Dotted line, right? Yeah. I'm pretty sure we do. Push it below. Push it below.
Did you annotate your inequality?
So we shade below.
Alright, let's pause. Put your pencils down.
We didn't do the
Alright, so what do I start at to graph?
negative 2.
Negative 2. And then is it a positive slope or a negative slope?
Positive.
Okay, so I'm going to be working to the right and my graph needs to be going like that. So I go up 2 over 3, right? Down 2 over 3. There we go. So your line should look something like that, yep?
Yeah.
Alright, now let's annotate my inequality. Y is what?
Y is less than.
Less than, so which direction am I going to shade?
Well, I don't know.
I'm going to shade below. Is it a dashed line or a solid boundary line?
Dotted.
Okay. So I'm going to doot. And then I'm going to pick an arrow, and if I'm shading below, my arrow will point this way. Whoop. Alright. Who picked 3 solutions? Or Rob, give me one.
2, -3.
Is over 2, -3 in the solution? Okay, what's another?
0, 8.
0, 8 over 0, what?
0, 8. Oh, negative.
Okay, there we go. 0, -8. Would that be in there?
Yeah.
What's another one? 6, 0 over 6 up 0. Let me ask you a question. Is 3, 0 a solution set?
No.
Why not?
Because it's a dotted line.
On the line. So if it's when it's on a dotted line, these are not going to be part of your solution. Okay? Which ordered pair do you want to choose to check?
0.
Pick one of them and check. Or if you picked a different one. So pick an ordered pair in the solution set, plug it into check.
You said 0, -6. 6, 0. Yeah, I didn't do anything. We do Y versus 0.
You're not solving for anything, you're just solving to see if it's true or false.
Do 0 is less than 2/3 parentheses 6. Who got plugged into this? Oh yeah. Wait, no.
Alright, give me an ordered pair to check.
0,
8? 0, -8. So I'm going to label my x and my y, and I'm plugging it into the inequality. So if I have y is less than 2/3 x minus 2, for my y value I'm going to plug in -8 is less than 2/3 times 0 minus 2. So now I just solve it out to make a true or false statement.
Yeah. 0.
So I get -8 is less than -2. Is that true or false?
True.
True. So did I shade the correct direction? Yes. If you get a false statement, you have shaded the wrong direction. Be very careful with the negatives, because that's what tricked them last year on a test. If they were in a hurry or on a paper, they saw 8 and 2 and said, oh, false. So watch your negatives. The larger the negative, the smaller the value. Yeah?
8 and 2.
Let's move on.
Huh?
We already talked about that.
What time is it?
8:50. Alright, so now what happens when we're given a shaded graph and we have to make the inequality ourselves? With your person, find the slope-intercept inequality of this. Go. I'll come back together. Find what slope inequality would represent this graph.
So the y-intercept is 3.
No.
We plug it in. -1/4. Y equals -1/4 plus so y equals -4/4. have loud doors.
Yeah, every door in here is loud.
I feel like the school should have the doors quiet because then it's like very distracting.
That way you talk much.
I did it.
You're learning at lunch. You can talk all you want.
No, it didn't. We was here.
Alright, what's the first point you chose?
Zero three.
0, 3. Typically start at your y-intercept, right? Okay, what point is a perfect point that you went to?
Negative 1.
So that's a perfect point. I'd say that's a perfect point. You gotta look for your perfect points to calculate slope. So I could rise 1 and then run 1, 2, 3, 4. If you had Desmos up on a real occasion, I would put the 2 points. What?
Yeah, you flipped it.
Ooh. There we go. Is this a negative slope or a positive slope?
Negative.
Okay, because we start at the left and we work our way down. Positive slope would work their way up to the right. So I have negative 1/4. I don't like touching that.
Happy birthday.
Plus 3.
Yeah.
Now, looking at our dots, is it shaded above or below?
Below.
Okay, so is it going to be less than or greater than?
Less than.
Is it a solid dotted line, solid boundary line, or dotted boundary line?
Dotted, so you can't pick any of them on the.
So it would just be this right here, yeah? Okay. Is 0, 3 a solution?
No.
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 Dotted line.
I like how Tucker said it. It's on the dotted line. If it's on the dotted, it cannot be a solution. If it's on a solid,
Yes.
what about 4, 4?
No, it's not even on the line. Or in the shaded area.
It's not even on the line or in the shaded. -2, -3?
Yes.
Over -2 over -3? Yes. Now for funsies, let's check 0, 3. Just for funsies, Brody. Because y'all look like you need some fun in your life.
Yeah. Did you get the attention today or tomorrow?
Today.
Oh,
So if I plugged in 0, 3 for my ordered pair, my y is 3, my x is 0, -1/4 times 0 is 0 plus 3. So I get 3 is less than 3. Is that a true statement or a false statement? False. So if you're ever unsure whether a point on the line is a solution or not, plug it into the inequality. Okay. Uno mas. Think about this one with your person. I'll give you 30 seconds. Think of something with me.
which one?
This one.
Oh. Only guacamole. Wait, there's only be a y value, so it means y equals
Inequality.
Yeah.
Oh,
Wait a minute.
Y is
Yes, it is.
y equals -3.
I
think it's gonna be an
Wait, Miss Grigsby, I got this. Wait. Let me see.
Alright, pause. Is it 0 slope or undefined? 0 slope. So it's going to be a y equals, right? Because it passes your y-axis.
Y is greater than -3.
Can it be y equals?
No.
Why not?
It's an inequality.
It's an inequality. So it's going to be y something.
It's greater than -3.
So if I put my dot, is the shading above?
Yes.
So is Giancarlo correct?
Yes.
And then is it greater than or equal to? Why is it equal to, Tucker?
Solid line.
Beautiful. So if I just have a straight line across, I would represent it with y is greater than or equal to -3. It would follow the 0 slope equation.
And follow the shade.
And follow
First
the
one is
shaded.
correct. -4, that's wrong.
Alrighty. You may clean up, my friends.
Yeah.